Hello my dear students. So now we have to start the new lesson for Form 5 Chemistry. The title of this lesson is Acids, Bases and Salt Preparations. So you can find this lesson in the pages between 173 to 187 in your textbook. So this is the content that I am going to cover up in this lesson. First, there is the theory of acids and bases, the reactions of acids with metals, salts, solubility of salts, bases and alkalis, salt preparations, and at the end the summary and few questions to be done by yourself and few references for your further study. So these are the learning objectives that you have to fulfill in this lesson. First, you should understand that the mechanism behind the reaction of acid-base reactions, and next, understanding the reactions of metals, bases and metal carbonates with hydrochloric acid, sulfuric acid and nitric acid, and next, understand the general rules for predicting the solubility of ionic compounds in water. For example, sodium ions, potassium ions, ammonium ions, nitrates, chlorides and hydroxyls. Understand the solubility of various oxides and hydroxides of metals and ammonia. Understand the preparation of soluble salts. So we will move to the theory of acids and bases. Here I am going to explain the theory of Bronsted-Lowry, and here I have given you some examples for acids. There is hydrochloric acid, which is HCl, nitric acid HNO3, sulfuric acid H2SO4, ethanoic acid CH3COOH, phosphoric acid H3PO4. Yes, if you take the example of HCl, that is hydrochloric acid, if we dissolve hydrochloric acid in water, it gives H3O plus ions and chloride ions. So these H3O plus ions are called the hydroxonium ions. So in this diagram you can see that the mechanism. So there is a water molecule and a HCl molecule. So in this situation, the bond between hydrogen and chlorine in hydrochloric acid molecule gets break, and the hydrogen atom becomes a proton and it gets attached to the lone pair of oxygen in the water molecule. So that as products you can see hydroxonium ion H3O plus and chloride ion has been given. Yes, next we will move to the theory behind the bases. So I have given some examples for alkalis. So what are alkalis? Yes, alkalis are the solutions that we can get by dissolving bases in water. So that I have given three examples: the sodium hydroxide solution, potassium hydroxide solution and ammonia solution. Yes, the sodium hydroxide when dissociate into sodium plus ions and hydroxyl ions, and also when ammonia is dissolved in water, it gets dissociated into ammonium ions, that is NH4 plus, and hydroxyl ions, that is OH minus. So by this diagram you can see that there is an ammonia molecule and also a water molecule. So you can see that one of the hydrogen bonds in H2O molecule gets break, and that hydrogen attaches with the lone pair of nitrogen in the ammonia molecule. So the products are the ammonium ion, that is NH4 plus, and hydroxyl ion, that is OH minus. Yes, if we combine those two equations together, we can get this complete equation of forming NH4Cl salt by the reaction of ammonia and HCl. So here ammonia can be identified as the base, where it's the proton acceptor, and HCl, the acid or the proton donor. Yes, with that we will move to the new subtopic, reactions of acids with metals. Yes, you can see the reactivity series of metal in this diagram. So starting from potassium to gold, you know that the reactivity of these metals are getting decreased, right? So if we consider about hydrogen, and also if we consider about a certain metal, if the position of that metal in the reactivity series is higher than the position of hydrogen, that metal is reacting with acids to produce H2 gas, right? If the position of this metal is below the position of hydrogen in the reactivity series, so we can identify that metal is not reacting with dilute acids. And at the same time, more vigorous reactions can occur by the reaction of higher metals and acids. So we know that when a metal is reacted with acid, it forms the salt and hydrogen. Yes, we will now see some reactions between some metals and acids. So here I have shown you the reactions between magnesium metal and zinc metal with sulfuric and hydrochloric acids. So reaction between magnesium and acids. When magnesium reacts with H2SO4, that forms magnesium sulfate, which is the salt, and hydrogen gas. When magnesium reacts with hydrochloric acid, it forms the magnesium chloride salt, that is MgCl2, and hydrogen gas. As same as that, zinc also reacts with sulfuric and hydrochloric acid. When zinc reacts with sulfuric acid, it forms zinc sulfate, the salt, and H2 gas. When zinc reacts with HCl, zinc chloride is formed and H2 is formed. Yes, apart from those two examples, there is an exception I have shown in this example. So if we react copper metal with sulfuric, would they react? Yes, they would not react, because here copper needs some special conditions. Here copper oxide has to be reacted with hot diluted sulfuric acid in order to get copper sulfate salt and water, right? Here the metal oxide is the one which reacts with acid in order to form salt and water. Yes, with that we will move to the next subtopic about salts. Okay, so what are salts? In general, when an acid and a base react, a salt is produced. When a metallic ion or an ammonium replaces one or more hydrogen ions in an acid, right? So here in the table I have given you some examples of acids, and also their formulae, and example of salts and name of the salts. First one, hydrochloric acid. So if hydrochloric acid gets that is HCl, react with sodium hydroxide, that is NaOH, it forms the salt sodium chloride, that is NaCl. So the name of the salt is chloride. When nitric acid, that is HNO3, reacts with potassium hydroxide KOH, it will form KNO3, that is potassium nitrate, that is the salt nitrate. When sulfuric acid, that is H2SO4, reacts with copper oxide, as I mentioned a little while ago, it will form copper sulfate, that is CuSO4, and name of the salt is sulfate. When ethanoic acid, that is CH3COOH, reacts with sodium hydroxide, it will form sodium ethanoate or sodium acetate. So the name of the salt is ethanoate. When phosphoric acid reacts with potassium hydroxide, that means when H3PO4 reacts with KOH, it will form K3PO4, that is potassium phosphate, and the name of this salt is phosphate. Yes, so this table shows you the solubility of different salts in water. So now we know what are salts and some examples how these salts are formed. So in this one you can see that all sodium, potassium and ammonium salts are soluble, and all nitrates are soluble. Most common chlorides are soluble except lead 2 chloride and silver chloride, right? If you consider about the sulfates, most of the common sulfates are soluble but except lead 2 sulfate, barium sulfate, silver sulfate and calcium sulfate, right? Yes. And if you consider about the carbonates, most common carbonates are insoluble and except sodium carbonate, potassium carbonate and ammonium carbonate, right? And also if you consider about the hydroxides, most metal hydroxides are insoluble or almost insoluble except the sodium hydroxide, potassium hydroxide and ammonium hydroxide, right? Calcium hydroxide and strontium hydroxide are slightly soluble in water. Yes, with that we will move to the bases and alkalis. So here we have to consider under 3 subtopics. They are the reaction between oxides and acids. Yes, if we consider about the reaction with oxides, the oxide of sodium, that is sodium oxide, when reacts with water, it will form sodium hydroxide solution. As same as that, potassium oxide also reacts with water and forms KOH, that is potassium hydroxide, and when calcium oxide reacts with water, it will form calcium hydroxide solution. So as I mentioned previously, sodium hydroxide and potassium hydroxide are soluble in water, whereas calcium hydroxide is slightly soluble in water, right? So next one, reaction between hydroxides and acids. So we can consider the reaction between sodium hydroxide and hydrochloric acid. By reacting those two, sodium chloride and water is produced, right? In this reaction, we cannot see a clear change that the products have been produced because sodium chloride is a colorless solution. So that we have to use a thermometer and we can keep that thermometer inside the beaker so that we can see a temperature change. From that temperature change, we can get to know that a reaction has occurred inside the solution, right? Next, reaction between carbonates and acids. Here I have considered about the carbonate of copper, that is copper carbonate. When copper carbonate is reacted with sulfuric, that forms copper sulfate, carbon dioxide and H2O. This copper sulfate is bluish green color. When copper carbonate reacts with nitric acid, it forms copper nitrate, carbon dioxide and water. When copper carbonate reacts with hydrochloric acid, it forms copper chloride, carbon dioxide and water. Yes, with that we come to the methods of salt preparations. Here I have given you the preparation of copper sulfate crystals, magnesium sulfate crystals and sodium sulfate crystals. And also after this, the preparation of potassium, sodium and ammonium salts, right? So the first one, copper sulfate crystals. When copper oxide is reacted with sulfuric acid, now you know that equation. When copper oxide is reacted with sulfuric acid, it forms the copper sulfate and water. And if this copper sulfate further reacted with water, it forms the hydrated form of copper sulfate. So in the picture you can see that the white one is the copper sulfate CuSO4, and after it is treated with more water, it forms the copper sulfate hydrated form, right? So next, magnesium sulfate crystals. So here magnesium metal has reacted with sulfuric acid and formed magnesium sulfate solution and H2 gas. And when this magnesium sulfate is further reacted with water, it has formed magnesium sulfate dot 7H2O, right? So when we add the magnesium, the reaction mixture will fizz, right? As in the picture you can see that when we keep adding magnesium until the fizzing stops and there is magnesium left in the beaker, this means that all the acid has reacted, right? In the first equation, for the formation of the solution of magnesium sulfate, it is magnesium plus sulfuric gives magnesium sulfate and H2. And again, the solution when is concentrated by heating it and allowed to crystalline, right? So that the crystallization reaction is the magnesium sulfate plus 7H2O gives magnesium sulfate dot 7H2O, right? Next, sodium sulfate crystals. There, sodium hydroxide base is reacted with sulfuric acid so that it produces sodium sulfate and water. Here, sodium sulfate when further reacted with water, it gets crystallized and forms the crystals like in the last picture, right? Yes. With that, we come to the preparation of sodium, potassium and ammonium salts. So, why the preparation of sodium, potassium and ammonium salts are different from the preparation of the previously mentioned salts? Yes? Yes. The reason why compounds made out of potassium, sodium and ammonium need special procedure is that they are soluble in water. You know that the compounds made of sodium, potassium and ammonium are soluble in water. So the solid compound you add to the acid wouldn't only react with the acid, but also they will get dissolved when excess water is present. So in order to examine when you have added just enough of the solid to neutralize the acid, we can use some other technique called titrations, right? Yes, now we will see the equations. So when sodium hydroxide reacts with sulfuric acid, it forms sodium sulfate. And when this sodium sulfate further reacts with water, it will form a complex sodium sulfate dot 10H2O. Right. When sodium hydroxide reacts with hydrochloric acid, it produces sodium chloride and water. And in the last equation, when ammonia reacts with sulfuric acid, it forms ammonium sulfate. Right? As all those products are soluble in water, we have to use the titration methods. Yes, with that we come to the end of the lesson. So this is the summary. Here you can remember that an acid is a hydrogen ion donor and a base is a hydrogen ion acceptor. Dilute acids react with metals depending on their positions in the reactivity series with relevant to the position of hydrogen. Examples for bases are metal oxides, metal hydroxides and ammonia. Some bases dissolve in water to form solutions containing hydroxyl ions which result in alkalines. Alkalines are a source of hydroxyl ions in solution. All sodium, potassium and ammonium compounds are soluble. Most metal hydroxides are insoluble in water except for sodium hydroxide, potassium hydroxide and calcium hydroxide, which is slightly soluble. And also all the nitrates are soluble in water. Yes, so there are some questions that you can answer by yourself. There are chapter questions 1 and 10 on your textbook, so you can answer them. And here are 3 of the references that you can use for your further studies. Yes, with that we come to the end. So thank you for your nice attention.